Welcome to chapter 7.2. If you recall, in our previous video, we looked at adding and subtracting polynomials. Well, today we are going to look at multiplying and dividing polynomials. Before we get started on that, there's a few important terms that we need to talk about. First of all is this thing called the GCF, or the greatest common factor. Remember, factors are two or more numbers that you would multiply together in order to get a product. For example, factors of 12 would be like 2 times 6 or 3 times 4. Or you could factor it all the way down to 2 times 2 times 3. Those would be the factors of 12. And we're going to use that today when we're talking about dividing polynomials. But before we get to that, let's talk about multiplying polynomials. And there's two techniques for that. The distributive property, which you are familiar with. And remember, when we distribute with polynomials, each term in one polynomial must be multiplied to each term in the other polynomial. And you'll see how that goes as we do a few examples. The other method that we're going to talk about is the box method. And this is a very visual method for us when it comes to multiplying binomials or any polynomials. And here's just an example. Let's say we're going to multiply 2x plus 7 times 3x minus 5. We can set up a box so that the length of that box is one term, 2x plus 7, and the width of that box is my other polynomial, 3x minus 5. And then we will multiply our rows and our columns. So 3x times 2x results in 6x squared. 3x times 7 is 21x, 2x and a negative 5 is negative 10x, and then negative 5 and 7 is negative 35. So the product is the result of combining our like terms here, and that would get us 6x squared. Combine the negative 10x and the 21x, that's going to give me positive 11x, and then finally minus 35. Now, if we did the distributive property, we would get the same result because we'd end up with 2x times 3x, which is 6x squared, our 2x times our negative 5, which is negative 10x, a 7 times our 3x, which is positive 21x, and then finally our 7 times our negative 5, which is negative 35. So you can see either method is going to lead to the same result. When I combine these like terms here in the middle, I'll end up with the same 6x squared plus 11x minus 35. So let's try a few more examples of multiplying before we get into dividing. Multiply the following polynomials using one of the methods above. Let's first distribute in letter A. That gives me negative 2x times 3x, which is negative 6x squared. Negative 2x times that 7 is negative 14x. And we're done with that one. Our next one, let's set up our box method. In our first side of our box, we'll let the terms 3x squared and negative 2 go along one edge. And then along the top edge, we'll put our larger polynomial, 5x squared minus 2x plus 6. All right, now we're going to multiply our rows and columns, and then we'll combine our like terms. Our first intersection here is 3x squared and 5x squared. That gives me 15x to the fourth. Now I have a positive 3x squared and negative 2x. That's negative 6x cubed. Our 3x squared and our 6 gives us a positive 18x squared. Our 5x squared and negative 2 gives us a negative 10x squared. Our negative 2 and our negative 2x results in a positive 4x. And then finally, our negative 2 and positive 6 results in negative 12. All right, looking across these 6 boxes, I see that I do have some like terms. It's negative 10x squared and positive 18x squared. And I must combine those when I simplify it. So the product of these two polynomials will result in 15x to the fourth minus 6x cubed plus 8x squared plus 4x minus 12. And it's always good practice to write that product in standard form, which remember means in decreasing order of exponents. All right, in example 2, we get a little bit of practice with this greatest common factor. And what we're going to do here is we're going to factor out the GCF from the terms of our polynomial. So for example, if we take a look at A, we have 4x cubed minus 12x times y squared. What you want to ask yourself is, what is a common factor that divides evenly into those two terms? And I can divide 4 by 4, and I can divide negative 12 by 4. So 4 I can factor out. I can also factor out an x, because I have x cubed and I have x to the first. So the GCF for x can be factored out of the two terms of this binomial. Now when I do that, I'm going to be left with x squared minus 3y squared. Now I know this is a little bit spooky here. Here's what happened. I essentially did the reverse of the distributive property. I divided out that common factor, 4x. Now, if I were to put it back in with the distributive property, you would see that you would get what we started off with. 4x times x squared is 4x cubed, and 4x times a negative 3y squared would result in negative 12xy squared. So when we are factoring out or dividing out the greatest common factor, it's essentially like the reverse of the distributive property. All right, let's try this next one. Letter B. I've got 15ab squared minus 27a squared b minus 39ab. Well, I know that 3 divides evenly into all those three numbers, 15, negative 27, negative 39. And all three of these terms have an a to the first power and a b to the first power. So I'm going to divide out a 3ab from each of these three terms. And when I do that, I'm going to be left with 5b minus 9a minus 13. All right, now just check yourself. If you were to distribute that back in, wouldn't you end up with the exact same polynomial that we started with? All right, let's move into example 3. Now we're going to divide some polynomials, and essentially we're ready for this because we just did it. If I take the binomial 6x squared minus 15x cubed and divide it by 3x, I have to divide both terms by 3x. So essentially what I'm doing is I am dividing each of these guys by 3x. So 6x squared divided by 3x results in 2x minus 15x cubed divided by 3x results in minus 5x squared. All right, take a second, make sure you understand that. Let's go to the next one. We got B, which says 5y plus 20 divided by y plus 4. Well, it doesn't look like we can really divide anything out there. However, I am going to factor out a GCF of that numerator. I can divide a 5 out of the 5y plus 20. And that leaves me with 5 times the polynomial y plus 4. And then I'm going to divide that by that same y plus 4. Well, what happens when we have the same thing in the numerator as we do in the denominator? They reduce to 1. And so what I'm left with is just 5. All right, letter C. We have something very similar, although I can see right away I have a factor in the numerator and in the denominator that are the same. So I'm going to reduce those to 1 right away. Now I have 3x plus 12 divided by x plus 4. Well, I can see that I have a GCF, a greatest common factor, of 3x and 12. And that number is 3. When I divide out a 3, I'm going to be left with 3 times x plus 4. And that's going to be divided by x plus 4. Now I have the same thing in the numerator as I do in the denominator, so those reduce to 1, and my final result is 3. All right, dividing polynomials is very tricky. We'll get lots of practice in class. Let's do another example of finding a polynomial function that represents the volume of the container. Well, volume, remember, is length times width times height. So I have polynomial expressions for all three of those measurements, length, width, and height, and I simply need to multiply those together. So I'm going to take the expression x plus 4 and multiply it to the polynomial 4x minus 2, and then I'm going to multiply that by x plus 3. Now, when we multiply more than one polynomial, or more than two polynomials together, we're just going to take two at a time. It's just like multiplying 2 times 3 times 6. You just multiply two at a time, take that product, and multiply it to the next factor. So here, we're going to do the same thing. We're just going to take these first two, multiply them together, and I'm going to use the distributive property. That's x times 4x, which is 4x squared, x times a negative 2, which is negative 2x. Now I'm going to take 4 times 4x, which is positive 16x, and then 4 times that negative 2, which is minus 8. Combining our like terms here in the middle, I have 4x squared plus 14x minus 8. Now I can take this polynomial and multiply it to my last one, which was x plus 3. All right, so once again, we'll use the distributive property to get that volume, and we're going to do x times all three of those terms, which gives us 4x cubed plus 14x squared minus 8x. And now we got to distribute a 3 to all three of those terms, and that's going to give us plus 12x squared plus 52x, and then minus 24. All right, once you combine your like terms, you will now have the volume of this container as a polynomial expression.